Hello everyone, I'm Obin and welcome back to my YouTube channel. In this tutorial series, we're going to create a real-world web application using ASP.NET Core Web API for the backend and a corresponding Next.js frontend to consume it. My goal is to not only teach you the essential concepts, but also to guide you through building a fully functional full-stack application. Here's what we'll be covering: vertical slices architecture. We will start by understanding and implementing this architectural pattern to ensure our application remains organized and scalable. Persistence. We'll learn how to integrate database persistence into our application. Minimal API endpoints. We'll focus on creating clean and efficient API endpoints. Authentication. We will implement authentication using JSON Web Tokens for secure user access authorization. We will implement control access to various parts of the application based on user roles and permissions. Cross-cutting concerns. We will address common concerns like login, exception handling, and validation. CQRS design pattern. We will understand and implement the command query responsibility segregation pattern using Mediator. Real-time application. We will explore real-time communication between client and server using Signal R. Next.js front-end. We'll build a dynamic and interactive front-end using Next.js. Next.auth. Implement authentication in the Next.js front-end using Next.auth. Tailwind CSS. We will use Tailwind CSS for rapid and responsive styling. Now, whether you're learning to build your first ASP.NET Core application, or you're already building web APIs, or just for fun, I'm sure this video will help you solidify the underlying concepts and workflows of building web APIs with ASP.NET Core. Throughout this series, we will strike a balance between theory and practice, ensuring you have just enough theoretical understanding to apply concepts effectively. Before we dive in, make sure you have Visual Studio Code installed. If not, you can download it for free from the official Visual Studio website. Additionally, we'll be using .NET SDK version 8 for this tutorial, so be sure to install it if you haven't already. Now, if you need any help or want to connect with fellow learners, you can join our Discord community. Find the link in the description below. For the full source code of this tutorial is available on my GitHub, also linked in the description. To stay updated on new episodes, hit the subscribe button and don't forget to like this video. Your support will keep this channel going. Now let's jump right into the first section where we'll be covering basic REST API concepts, ASP.NET Core fundamentals, and start building our application using vertical slices architecture. Before diving into REST APIs, let's grasp the fundamentals of how the internet operates. Imagine the internet as a vast network of interconnected devices, including computers, phones, and servers. When you interact with a website or an app, your device communicates with a server to retrieve the necessary information. This interaction between your device and the server occurs via a specialized protocol known as HTTP, standing for Hypertext Transfer Protocol. HTTP serves as the common language understandable by both your device and the server. When you enter a website's address into your browser and hit enter, your browser dispatches an HTTP request to the server asking for the web page or resource associated with that ad. The server then processes this request, retrieves the requested web page or resource, and sends it back to your browser, which then displays it for you to interact with or view. This process is fundamental to how the internet works, allowing users to access and navigate websites seamlessly. Now, here's the anatomy of an HTTP request. Method specifies the action your device intends to perform, such as get, retrieving information; post, submitting new information; put, modifying existing information; delete, erasing information. The URL of the resource being requested, headers specifying additional details or preferences, and optionally a message body containing data to be sent to the server. Once the server receives your request, it processes it and dispatches a response back to your device An HTTP response has the following elements: status code communicates to your device whether the request succeeded or encountered an issue. Example, failure to locate the requested resource, denoted by a 404 error. Headers, these are additional details about the response. Body represents the actual information your device sought, such as a web page or data. Now that you are equipped with the basics of the internet and HTTP operations, let's dive into REST APIs. So before we talk about REST APIs, we need to know what an API is. API stands for Application Programming Interface. It's a piece of software that defines how an application communicates with other applications. So Web API is a type of API that allows different applications to communicate over the internet. It relies on multiple communication protocols like HTTP, gRPC, SOAP. Now, what is a REST API? REST APIs, or representational state transfer APIs, are a type of web API that uses the HTTP protocol to send and receive data. It follows the request response model. They are stateless. This means that each request needs to contain all the information needed to process it. Leverages structured formats like JSON and XML, maintains segregation between applications requesting information and those providing it. They are the most widely used for data integration, facilitating efficient data transfer. Now that we've established a solid understanding of REST APIs and their crucial role in modern web development, let's see how ASP.NET Core leverages these concepts to implement REST APIs. Let's create an ASP.NET Core Web API. Open your integrated terminal. Let's check to make sure you're using the right version of .NET. All right, so we're using version 8.0.101. So if you don't have this version, please install it. This is the version we'll be using. Let's create a folder. ASP.NET Core. Foundation. Now move into this folder. Now inside this folder, let's create our web API. So let us open this folder inside VS Code instance. Add this flag to maintain the same instance of VS Code. This is the program CS flag that our template created for us. It is the entry point of our ASP.NET Core application. It will launch a host, which is responsible for starting the application. The host is also responsible for configuring the HTTP server and setting up the HTTP request pipeline for processing requests and responses over the HTTP protocol. In a nutshell, this is where we will configure everything we need to start writing our web API. Now, this is a minimal API hosting model. The code on the line 1 constructs the web application builder, which gives us the options to configure the application host. Now, let's take a look at some of the properties that we can configure by typing builder. And as you can see, we have the environment property, we have configuration, we can set configuration, providers, and we can configure the environment, we can configure the host, we can configure login and even add login providers, metrics, we can add services to our DI container, we can add all the necessary configuration that we need to build our application. Now the code on the line 3 calls the build method. This build method configures the web host and sets up the middleware pipeline for the application. Now the web application configures the request response pipeline. It allows us to configure and analyze in our application. It also has the run method. The run method that we can call that exposes the HTTP server and initiates the HTTP request response pipeline. In other words, it starts our application with a given port where it listens for incoming HTTP requests. There is an add.map method that allows handling of different HTTP verbs or methods. For instance, the map gets, it usually takes in two parameters. First parameter is the pattern that has to be matched for a handler to be called. We can call this a hello add. The second parameter is a handler. If the handler can be any function. For instance, we are going to use a lambda function hello path. Going to return hello path. It allows other methods too, like the post method. For the post method, let's say this is a post. This is a post. It has the push method. So this is a push. This is the push. And lastly, it has the delete method. Well, this is delete. All right, so when a client sends an HTTP request to one of our API endpoints, the HTTP core routes the request to the appropriate endpoints by matching the request URL with a specified route pattern. And when the route pattern is matched, the route handler is executed. It processes the request, executes any necessary business logic, and returns an HTTP response to the client. Now, route handlers are methods that execute when a route matches. It can be a function of any shape, including synchronous or asynchronous. It can be a lambda expression, a local function, an instance method, or a static method. This provides the appropriate flexibility when deciding how to organize your route handlers. Let's run the application. Hello world. Go to the hello path. Hello path. A fundamental concept in ASP.NET Core is middleware. Middleware acts as a pipeline between the client and the server, a pipeline of components that handle incoming HTTP requests and outgoing responses, executing tasks like request processing, logging, authentication, and authorization. Each middleware component in the pipeline is responsible for performing a specific task, such as authentication, login, or routing. ASP.NET Core provides a rich set of built-in middleware components that developers can use to enhance their applications. These components operate in a pipeline, with each one handling the request in a specific order. Now, the middleware pipeline is constructed using the iApplication Builder interface, which provides a fluent API for adding middleware components to the pipeline. The pipeline is constructed in program class, which is executed when the application starts. For instance, the HTTPS redirection middleware this is used to redirect all HTTP requests to HTTPS. Now, for this to work, let's go to Properties, Launch Settings, and under our profiles, let's remove the HTTP profile. In other words, we're just going to be using the HTTPS, which also has an option for HTTP. Save that and run the application again. This time we're going to run the application as watch. Not watch run. This will enable our application to run continuously. Hello world. Connection is secured. Now, aside the built-in middleware ASP.NET Core provides for us, We can create a middleware by calling the use method on the web application. Let us create some custom middleware. Whenever we want to add a middleware, use the use method of the web application. Helps us add a middleware to the pipeline. Now, inside this, we're going to add a function that takes two parameters, one of which is HTTP context, and the request delegate. We're going to await the request delegates. Now we're going to run our task here. If you want to run the task before the request is processed, you add it here. Let's write some things to the console. Incoming requests. Let us duplicate this and take it down and call this outgoing requests. Outgoing requests. Let's see what's going to happen. Our application is rebuilding. Okay, application has finished rebuilding. Let us run the application again. Let us send a request. Now what we're going to see is incoming request and outgoing request. Now to understand the dynamics of how this works, we're going to create another middleware. Call this incoming requests middleware 1, incoming request middleware 2, outgoing request middleware 1, outgoing request middleware 2. We're going to run the application and check the difference in the processing order. All right, the application has finished rebuilding. Let's run the request again. Okay, here's what we got. We have, incoming requests middleware 1, incoming requests middleware 2, outgoing requests middleware 2, incoming requests middleware 1. What does it tell you? It is taking a circular approach. It's almost like a circle, starts from M1, goes into M2 and returns back to middleware 2 and goes out from the middleware 1. Let's say this is our middleware pipeline. Application builder interface. This is our endpoints. So this is a middleware, and this is also a middleware. M1, M2. Let's call this M2. And this is the endpoint. All right, so when a request comes in to the application, the request will enter this place. And the request will first of all hit the M1. This middleware company will run a specific task on this request, such as login or authentication. Now, the middleware company can either pass the request on to the next middleware, in this case, middleware 2, or it can short circuit the pipeline and return a response directly to the client from middleware 1. Doesn't even need to get to the endpoint or the next middleware. So let's assume the middleware 1 runs the task like, say, login, logs the request and passes the request to the next middleware, which is this. This request is being processed in the middleware 2, or maybe authentication happens in the middleware 2, and it passes the request to the endpoint. In the endpoint, this request is being processed against business logic. Maybe a resource has been accessed from the database and is being passed as a response. Now, the response will start going back in the same order. From the endpoint, it will first of all hit the middleware 2. And if there's any post request task, it will happen now in the second middleware. It will still move from second middleware to the first middleware and back to the clients This is the basic concept behind ASP.NET Core Web APIs. When a client sends a request to your server, the request gets into the middleware pipeline. Now, the first middleware takes the request, processes it. If there is a reason to move it to the next, it moves it to the next middleware, and then next middleware before it gets to your endpoint. Now, your endpoint does its own processing, begins to send the response. The response follows the same path again, just like a circular path in that order, and sends it back to the client. Now, aside the built-in middleware ASP.NET Core provides for us, we can create a middleware by calling the use method on the web application. Now, let us create some custom middleware. Whenever we want to add a middleware, use the use method of the web application. Let's us add a middleware to the pipeline. Now, inside this, we're going to add a function that takes two parameters, one of which is HTTP context, and the request delegate. We're going to await the request delegate. Now we're going to run our task here. If you want to run the task before the request is processed, you add it here. Let's write some things to the console. Incoming requests. Let us duplicate this and take it down and call this outgoing requests. Outgoing requests. Let's see what's going to happen. Our application is rebuilding. Okay, application has finished rebuilding. Let us run the application again. Let us send a request. Now, what we're going to see is incoming request and outgoing request. Now, to understand the dynamics of how this works, we're going to create another middleware. Call this incoming requests middleware 1, incoming request middleware 2, outgoing request middleware 1, outgoing request middleware 2. We're going to run the application and check the difference in the processing order. All right, the application has finished rebuilding. Let's run the request again. Okay, here's what we got. We have, incoming requests middleware 1, incoming requests middleware 2, outgoing requests middleware 2, incoming requests middleware 1. What does it tell you? It is taking a circular approach. It's almost like a circle, starts from M1, goes into M2, and returns back to middleware 2 and goes out from the middleware 1. Let's say this is our middleware pipeline. Application builder interface. This is our endpoints. Call this is a middleware, and this is also a middleware. M1, M2. Let's call this M2. And this is the endpoint. All right, so when a request comes in to the application, the request will enter this place. The request will first of all hit the M1. This middleware company will run a specific task on this request, such as login or authentication. Now, the middleware component can either pass the request onto the next middleware, in this case, middleware 2, or it can short circuit the pipeline and return a response directly to the client from middleware 1. Doesn't even need to get to the endpoint or the next middleware. So let's assume the middleware 1 runs the task like, say, login, logs the request and passes the request to the next middleware. which is this. This request is being processed in the middleware 2, or maybe authentication happens in the middleware 2, and it passes the request to the endpoint. In the endpoint, this request is being processed against business logic. Maybe a resource has been accessed from the database and is being passed as a response. Now, the response will start going back in the same order. From the endpoint, it will first of all hit the middleware 2. And if there's any post request task, it will happen now in the second middleware. It will still move from second middleware to the first middleware and back to the clients. This is the basic concept behind ASP.NET Core Web APIs. When a client sends a request to your server, the request gets into the middleware pipeline. Now, the first middleware takes the request, processes it. If there's a reason to move it to the next, it moves it to the next middleware, and then next middleware before it gets to your endpoint. Now, your endpoint does its own processing, begins to send the response. The response follows the same path again, just like a circular path in that order, and sends it back to the client. Now, aside the built-in middleware ASP.NET Core provides for us, we can create a middleware by calling the use method on the web application. Now, let us create some custom middleware. Whenever we want to add a middleware, use the use method of the web application. Let's us add a middleware to the pipeline. Now, inside this, we're going to add a function that takes two parameters, one of which is HTTP context, and the request delegate. We're going to await the request delegate. Now we're going to run our task here. If you want to run the task before the request is processed, you add it here. Let's write some things to the console. Incoming requests. Let us duplicate this and take it down and call this outgoing requests. Outgoing requests. Let's see what's going to happen. Our application is rebuilding. Okay, application has finished rebuilding. Let us run the application again. Let us send a request. Now, what we're going to see is incoming request and outgoing request. Now, to understand the dynamics of how this works, we're going to create another middleware. Call this incoming requests middleware 1, incoming request middleware 2, outgoing request middleware 1, outgoing request middleware 2. We're going to run the application and check the difference in the processing order. All right, application has finished rebuilding. Let's run the request again. Okay, here's what we got. We have, incoming requests middleware 1, incoming requests middleware 2, outgoing requests middleware 2, incoming requests middleware 1. What does this tell you? It is taking a circular approach. It's almost like a circle, starts from M1, goes into M2, and returns back to middleware 2 and goes out from the middleware 1. Let's say this is our middleware pipeline. Application builder, application builder interface. This is our endpoints. Call this is a middleware, and this is also a middleware. M1, M2. Let's call this M2. And this is the endpoint. All right, so when a request comes in, to the application. The request we enter this place. The request will first of all hit the M1. This middleware company will run a specific task on this request, such as login or authentication. Now, the middleware component can either pass the request on to the next middleware, in this case, middleware 2, or it can short circuit the pipeline and return a response directly to the client from middleware 1. Doesn't even need to get to the endpoint or the next middleware. So let's assume the middleware 1 runs the task like say login, logs the request and passes the request to the next middleware, which is this. This request is being processed in the middleware 2, or maybe authentication happens in the middleware 2 and it passes the request to the endpoint. In the endpoint, this request is being processed against business logic. Maybe a resource has been accessed from the database and is being passed as a response. Now, the response will start going back in the same order. From the endpoint, it will first of all hit the middleware 2. And if there's any post request task, it will happen now in the second middleware. It will still move from second middleware to the first middleware and back to the clients. This is the basic concepts behind ASP.NET Core Web APIs. When a client sends a request to your server, the request gets into the middleware pipeline. Now, the first middleware takes the request, processes it. If there is a reason to move it to the next, it moves it to the next middleware, and then next middleware before it gets to your endpoint. Now, your endpoint does its own processing, begins to send the response. The response follows the same path again, just like a circular path in that order, and sends it back to the client. Another thing you need to bear in mind is that the order in which they are placed determines which middleware that processes the request first, and also the next function represents the next middleware in the pipeline, like you already know. Now let us show this example. Now let's rearrange the statements in the middleware number 1 and see how it is going to affect the order of execution. Now let us move the next delegate upwards. The application is running on watch mode, so anytime we make any changes, it will reflect. I hope you remember that. Let's go to the browser and send a request. Incoming requests M2, outgoing requests M2, incoming requests M1, outgoing requests M1. What did you notice? The second middleware ran first because the next middleware has been executed and the response is already coming back. So this request is no more a request. This is now a response. We can as well take it out. All right, so let's send a request. Check it out again. Okay, here's what we got. Incoming request M2, outgoing request M2. This way, the second middleware is being processed first before we even begin to process the first middleware. All right, having understood how the middleware works, we're going to create a login middleware that is going to use the HTTP context and log the details of an incoming request. Now, before we do that, we'll have to talk about what the HTTP context really is. HTTP context is a class in ASP.NET Core that encapsulates all HTTP specific information about an individual HTTP request. It provides access to various aspects of the request, such as headers, query, parameters, form, data. Let's examine the HTTP context object. HTTP context.requests, we can have access to the request body, can have access to query string, can have access to form data, can have access to cookies, and more. It also provides access to interacting with the response, such as setting headers. You can set response headers. You can also set status code. You can write content of the response. So the HTTP context plays a crucial role in processing and handling incoming HTTP requests, as well as generating appropriate responses. We are going to comment this out and create a new middleware. All right, so what we want to do here is we want to be able to intercept a request and log the details of the incoming request, and also log the details of the outgoing request. Await. Next. You can pass the context. Here we want to use our static logger that we can access from the web application. Going to log information, incoming request. Log the request method and also the request path. In this template, we're templating it. Let's get this object context dot request dot method. Whether it's a put request, whether it's a get request, whether it's a post request, we want to log it here. And also we want to log the path. Context.request path. I think we are good here. Let's break it down. You can see what we're doing. This is for incoming requests. Now for outgoing requests, we're going to log information, and we're also going to log the same thing, outgoing requests, 0, 1, context the response, that status code, response, that's content type. Let's break this down so we can see what we're doing. There's an error here. Okay, I used parentheses instead of curly brackets. All right, let's correct that. Let's uncomment the post endpoints. Let's create a simple class user. Name. A simple user class that has just name and age. Let's say age. And okay, this is good. So user class, we're going to pass it here. User. Let us return let's return the user. Return it back to the client. Let's run our application, test it out. Let's run. So let us copy this endpoint. We're not going to use the browser anymore. Copy the endpoint. Let's open it with our Thunder client. Now I'm going to use this Thunder client for testing. If you want to get this, you can go to extensions and search for Thunder client. It's an HTTP client for testing your APIs, just like Postman. So if you don't have this, you can easily download it. It makes testing your API very easy because it lives in VS Code. Let's create a new request. Let's use our own endpoints. Close this for now. Let's send the first request to the index URL, got hello world. Let us look at the terminal. Oh, I closed down the terminal. Let's open the terminal again. See, incoming request gets, and here is the path. Outgoing request 200. That is the status code, and then this is the content type. Let us test the next path, which is hello. Our middleware is logging the details. Incoming request is a get method. The path is /hello. Outgoing request is 200 status code, and here is the content type. Now let us test the last endpoint, the user, and it's a post method. Let's change this to post. We are going to be adding body. So in the body, we're going to add a JSON payload, which comprises of name. We're going to say opener and age. The age is, let's say, 16. I'm not 16, but let's just say 16. Send the code, send the request. We'll have 200. Okay, what was the response? The response is the same object that was sent over. So let us look at our middleware log. We have incoming request. The method is post. Path is /user. The status code is 200, and the content type is application/JSON. So in a nutshell, middleware are best used to handle cross-cutting concerns like logging, request validation, global exception handling, etc. Going forward in this tutorial, we're going to talk about another important feature of ASP.NET Core, which is dependency injection. Building an application will require you to create services which have dependencies on other services or components. These dependencies are typically injected into the service's constructor or method parameters, allowing the service to fulfill its responsibilities effectively. By using dependency injection, you can achieve loose coupling between components, promote modularity, facilitate testing, and enhance the maintainability and scalability of your application. Now, how does dependency injection work in ASP.NET Core? ASP.NET Core provides an iService collection interface, which serves as a container for registering application services. Now, where do we find this iService collection interface? If you go to build a class, you have the service method, which returns a collection. Now, if you hover over this, you will see that the services method returns an iService collection, which is a collection of services for the application to compose. This is useful for adding user-provided or framework-provided services. Services can be registered using different methods. These methods specify their lifetimes. We have the add transient method. In this particular method, a new instance of the service is created each time it is requested. We also have the add scoped method. In this method, a single instance of the service is created per HTTP request. And then we have the last one, which is add single thing. In this case, a single instance of the service is created for the lifetime of the application. This is a global instance. Creates it once and it shares it across the application once until the application stops. All right, so dependency injection in ASP.NET Core automatically resolves dependencies by injecting the required services into the controller of a class or a method parameter. You can request services by declaring them as parameters in the constructors of your controllers or middleware or other components of your application. The ASP.NET Core runtime manages the creation and disposal of service instances based on their registered lifetimes. Now let's create a GUID service and register it with the DI container. Let's remove this. Uncomment this out. Let's clean up. Let us create an interface. We're going to call it iGUID service. This interface will have just one method, and this method we're going to call it getGUID. Let's create the concrete service that will implement this GUID service. We're going to call it GUID service. implement interface, private read-only garage ID. Let us create a constructor that will generate this GUID each time we call this service. ID is equal to GUID get new GUID. So just call the ID method. All right, so we've implemented iGUID service. Now let us register it to our container. We'll first of all register the service to the DI container with a transient lifetime. Builder.services .add transients. And GUID service. GUID service. Let us create an endpoint to handle the GUID requests. Comment this guy out. Let's say GUID. iGUID service. Parameter. No, we're trying to resolve this service through method injection in this instance. So we are going to return the GUID service. Get GUID. Now let's run the app and test what we got. We're going to run this app as watch. Each time we make an update, we don't need to run the app again. Let us test our GUID service. Go to this routes. You send the request, you get a new GUID. Each time you request the service, for instance, let's print the GUID to the console from the middleware pipeline. We're going to reuse the middleware pipeline we had already. I'm going to remove this for now. I'm going to remove this. If you notice, the middleware was still logging the details of our requests. Now let us uncomment this middleware because we're going to use it to test this lifetime and how it works. So let us access our GUID service in our middleware pipeline. Let us uncomment this, push it upwards, remove this. We may not be needing this. Let us get our GUID service. GUID service from HTTP contest dot request services. Let's get buyout services. The service we want to get is iGUID service, right? All right, so this is another way to resolve your services. You resolve it through the HTTP context request services property. We're going to log it to the console, create your service dot GUID. We're logging it directly to the console. Let's run this app and see what we're going to get. Our application is running now. Let's try our app out. As you can see, it's logging a different instance for each request. Each time you make a request for the GUID service, it logs a different instance. Let's send the request again. This is a different one, and it's different from the one that's been logged here, which is this. See, so each time you request a service that is registered with transient lifetime, it gives you a new instance each time you make a request on it. This demonstrates lifetime of a service registered with add transient. Let's change the lifetime to scopes. We're going to comment this out. Change the lifetime to scopes. We're going to test run this. The scope's lifetime will resolve the services only once throughout the lifetime of that request. Okay, now let's run the request. Let's use the last few digits using 9621. Let's check our, okay, we'll have the same thing 9621. So it's the same throughout the lifetime of the request. So each time you access a scoped service throughout the lifetime of a single HTTP request, it is going to return the same instance of the service. I'm going to do something interesting now. I'm going to call the services inside the second middleware. We'll remove this, call it inside here. Gateway service. Let's get created. Give this name so I will know the services that we're accessing. The first service, this is the first service requested. I'm going to use the same format. With the second service request. Second service request. I'm going to create a third one. A third service request that is going to create a service with a different scope. This scope is different from the request context scope. So we're going to get it from a new scope. So how do we do that? We say using, inside the using statement, we say var scope is equal to HTTP context dot request services dot create scope. We created a new scope. Now inside this scope, we're going to get our different scopes queued service. What a long name. The intention is just so it's descriptive enough. Get it from the scope dot service provider dot get request service. Get service is going to be iGateway service. iGateway service. So we are going to console write this scope service. Let us template it. This is going to be the third, and this will be the second instead. Second service. Oh my God. For this one, let us do some templating too. Interpolation, that's what we're going to do here. This is going to be the fourth service request. Let's test run our application. Let's run the request. We'll have an error. Okay. Sorry about that. We're supposed to start from 0. So this is a zero index. The zero index arrangement. So if you made that mistake, please correct it. Our request has run. See what we have. Incoming request M1. First service request. The second service request is different. The third service request is the same with the first one. Now let us check the fourth one. The fourth service request is the same with the first and the third. Only the second service request is different. We used a new scope, which is a scope outside the request context. When you add a service as scoped, it means a new instance of that service will be created once per request within that scope. This scope is a different scope from the request scope. I hope you understand this. Scope in programming means an abstract separation, an abstract separation of code, logic, or statements. So this right here is just a different scope with different lifetime, and the lifetime is within this scope. Once it finishes using the service here, it will dispose of it. Now let's switch the registration to the singleton. The singleton registration has a global scope. Comment this one out. Comment that. And singleton. Take note of the GUI that was created here. It's the same here. It's the same on the second one, which has a different scope. It's the same on the third service. So what this means is all the services that was requested at the same instance. This means that the service is being created once throughout the lifetime of the application, which is outside the scope of the request. So no matter when or how or where you access this service, it returns the same object because it is global. So far, we have shown the method injection with the GUI right handler. Now let us inject the argue service through the constructor to demonstrate constructor injection of dependencies. Create a new class, call it consume GUI service. We're going to inject this GUI service inside the constructor of this class. Now let us create a property. We're going to call this property ID. We're going to return a GUI, and we're going to set it to GUI service. Get GUI. Register the service to be container service collection container. I'm going to use let's register it with consume and comment this part to add this service as a transient. Having added the consume GUI service to our container, we have to replace these services with a new service, which is consume GUI service. I'm going to replace this with this. We're going to call the ID to property and not the method. So we'll just call the ID. For this, we're going to replace this with this. For the ID. Let's replace that here. So let's replace this with ID, and the last, which is the endpoint that we are calling. Let's replace the endpoint for ID, remove the parentheses, and save. Alright, so the first service request has this GUID. The GUID is the same across all of them because we registered it as a single thing service. So whether using constructor injection or property injection or method injection, the goal is to decouple dependencies and promote code that is easier to understand, maintain, test, scale, extend. Maintainability is one of the core tenets of software development. Our applications should be easy to maintain and adaptive to change. One of the go-to approaches to attain maintainability is to achieve separation of concern. The traditional approach to software architecture splits the application into separate layers to achieve this, therefore forming the layered architecture. Examples of the layered architecture are entire architecture, onion architecture, and clean architecture. The layered architecture is a design method that organizes the system components or modules into distinct layers, each responsible for specific functionalities. The typical structure is to create projects or libraries that deal with UI layer, the application layer, the domain layer, and the infrastructure layer. These layers are organized based on technical concerns. The vertical slices architecture style is about organizing code by features instead of organizing by technical concerns. It's about an idea of grouping code according to their business functionality and putting all the relevant code close together. The vertical slices architecture can be a starting point and can be evolved later when an application becomes more sophisticated. Now we are going to implement vertical slices architecture. Let's start by creating a new folder named Study Lounge. Now move into this folder. Now inside the folder, let's create a solution file that we'll use to organize our projects. We'll name it Study Lounge. Now that we've created our solution file, let's create the API project. We'll save this API project inside the source folder and API folder. Let's enter to create a project. All right. All right, so let's create the application folder. The application folder is going to be a class library project, and the name is going to be application. Now we're going to add the projects to the solution file because these are just the two major projects that we're going to be using for this architecture. Let's add the good. I've added that to the solution file. Let's add the application project to the solution file. Slash API slash application slash application. Let's CS proj. Now we can also create a test project and add to the solution file, but for now we'll leave that out and focus on creating our vertical slices architecture. Let's add a git ignore file now. All right, git has been initiated. Let us open this project in our VS Code. See what we've got. We have our study lounge solution file that we created and has our application and API projects in them. So this is our git ignore file, and our git has been initiated. Now let us look into our API project and see what is going on there. Now let us add a reference of the application project, the API project. .NET add API .cs proj reference. Go to API.cs proj. You'll see that we've added the application reference to our API project. We've been able to establish the framework for our vertical slices architecture. To run your application, you have to open terminal. Just right click the API project, click open in integrated terminal. You will have the API project opened. So we'll now run .NET, see if our application is set up correctly. All right, so here is the class diagram of the Study Lounge app that we're going to be creating. This class diagram has different classes which represents different features that we're going to be building around our Study Lounge app using vertical slices architecture. It has the user class, the group class, the study session class, the collaborative notes, the direct message, friendship, material, group chat message, session go. Barely looking at this class diagram, you'll be able to identify the key components and features of our Study Lounge application that we're about to build. Basically, we're going to take this class diagram and implement this in our API. We'll start out with implementing the user feature, which is central to all other components on this system. If you notice, the user class uploads study material. The user class owns a group. The user class is also a member of a group. The user class participates in study sessions. The user class creates or contributes to collaborative notes. The user class sends and receives direct messages. The user class has friendship. There are other classes that relate to themselves. You have the group. The group has sessions, and also the session sends group chat messages, and the session sets session goals. There's a lot of features in this application we are trying to build. So we are going to take them feature by feature so that we can appreciate the advantage of using the vertical slices architecture. Let's jump right into the VS Code and begin to implement our user feature. To add the user feature, we're going to add some required packages to the application project. Before we do that, let us check our Git status. All right, so let us add this to Git to track. Okay, now we're tracking our files. Let us commit this as initial commit. Now open the application project in the integrated terminal. Now let us go ahead and add these packages to our application project. Open the application.cs project file. Now add the packages. Let's add package Microsoft ASP for identity. Next package .NET add package Microsoft .ASP.NET for .identity .entity framework call. Then .NET add package Now let us go to our API project and open it in an integrated terminal. Open the API project file. Let's add the EF4 design package. Since we are using Postgre in this project, make sure to have Postgre server running on your machine. You can follow the instruction on the README file of the repository to install it and run Postgres on Docker. In the application project, go to new folder, call it infrastructure. Inside this folder, let's create the identity folder. The identity folder is going to contain all the logic responsible for managing the user's identity. So inside the identity folder, let's create the application user. Create a new class, call it application user CS. And the namespace. The namespace is going to be story launch. Application infrastructure identity. All right, so let's add the class. Application user. And the application user is going to inherit from identity user class. Let's import the identity user class from the identity package. Let us add the properties of this user class. It's going to be a nullable string, and we'll call this display name. Get this in multiple places. Replace this with int. It's going to be the age. This is going to be the gender. Gender is going to be an enum. Create this enum class. We'll create this enum type later. Location. Avatar. Profile. And URL. About me. Last but not the least, this is going to be a book. Active. Let's create the gender. Gender. The basic user properties like email, username, password, etc. are provided by the identity user class. In the infrastructure folder, create a new folder called persistence. Inside persistence, let's create the AppDB context class. Namespace, application, infrastructure, persistence. This is going to inherit from identity DB context class. Let's add our application user. Let's add a constructor. Let's override the onModel creating method. Model builder. That's the builder state. Now we can add additional configuration. The next thing we're going to do is to add our connection string. Go to the API project. Inside the app settings.development file, add a new section called base connection string. What's action? Hosts. Go to localhost. The port is 5432. This is the default port for Postgres database. Database name is going to be the lounge. DB. The username equal to root. Add the username you use in setting up your own database. Password is going to be equal to 123456. Add any password you choose to, but make sure your password is a strong one. This is for demonstration purposes. Include error detailing. Important. Want to be able to see the error details of the console. The next thing we're going to do is to register the DB context. So in the persistence folder, create a dependency injection class. Create a new class for the dependency injection. And space. Launch. Systems. All right, let's add the extension class. This class is going to have a method that returns the iService collection. We'll call this add persistence. Is iService collection services. Also, it takes the parameter of the eye configuration interface. We can return the services dot add DB context. So let's add our DB context class. Now this is going to take some options. Let's configure this option, database options, options.use Postgres database. Add a connection string. Let's define the migration assembly type of add DB context. Assembly remain. Let's do the same for the identity class. Let's just copy this dependency injection, paste it in the identity folder, and we're going to change a couple of things. Change this to identity and change this to identity config. We would need this configuration. Remove all of this services that add identity. We're going to take application user and identity rows. Configure the options. Let's configure the password validation requirements. Let's say required length 6 digits. Options.user. Let's require unique email. This is going to be true. Let's add entity framework stores. We're going to have our app DB contest. Now let's add default token providers that will enable us to generate tokens. I move this return. Let's return services. Okay, remove this S. Let's create a dependency injection class in the application root folder. Space for the group for the launch application public static plus dependency injection. This is going to contain the application-wide service registrations. You know the drill. Create another static method that returns iService collection. iService collection. And infrastructure. type configuration. We're going to return services that are persistence. We pass the configuration objects, and we're going to also add the identity config. Now register this extension method in the program class of the API project. View data services. Let's add infrastructure. And builder with configuration. Add the using statement on top. Double application. Now we need to create the initial migration for the AppDB context. Open the integrated terminal in the folder where our solution file is. Let's check to make sure our database is running. All right. Postgre database is running. Let's run .NET. With migrations at initial migration. Add the project reference. Output directly. Migrations. All right, so this has scaffolded our migration file based on the AppDB context. Now let us go through the migration file. Go to infrastructure, data, migration. We'll see the initial migration file that was created. Now it has ASP.NET roles table, ASP.NET users table was also, created. Look at this migration details, you will notice that all the properties in the application user class are here, including the username, email, password, and other properties that comes with the identity user class. So they're all added. So now what we're going to do is apply the migration to the database. To do that, we'll say .NET VF database update. We add a project reference. Startup project reference. All right, so our migration has been applied. Let's go back to the database and check if our database exists. All right, let's refresh this. Okay, here's our database, the database that was just created. Now it has one schema, public schema, then open tables. collection, we see that we have all of those tables created for us in our database. Now, the next thing we're going to do is to define the iUser service interface. Go to the application project, create a new folder. This folder, we're going to call it features. This is where all the features of our applications are going to be, the feature slices. And the first feature slice is the users. Let's create a folder called users. Now, inside this folder, we are going to create the iUser service interface. Add namespace. Add the interface. This interface is going to have a single method for now. Ask task. This method is going to return a string. Wait. Missing. Add a DTO class. Create user requests. Requests. Now let us create another class called create user. Let's add the namespace, body, the applications, the application, the features, the users. Now inside this class, we're going to create the create user request VTO class. Now inside this class, we are going to create a create user request record. We're going to use a record. String email, string password. All right, so let's implement the iUser service interface in the identity folder of our infrastructure folder. Let's go to the identity folder and create the concrete class user service .cs. And the namespace story launch dot creation dot infrastructure dot identity public class user service iUser service iUser service interface. Let's implement that method. Let's create the user, meaning application user, email is equal to request.email, username is equal to request.email, and is active equal to true. The user has to be active as soon as we create it. All right, so we need to inject the user manager to this service. Let's inject user manager. Patient user. So let's user manager. Okay. So let us register this user. So user manager results is equal to await user manager. So create the same. And inside we're going to add our user and the request password. So we're going to do some error handling, check if the results got succeeded. Undo the error here. Error. In the later chapters of this series, we are going to talk about how to do global error handling using a better way other than exception. But for now, we're going to throw an exception. Throw new exception. Let's extract the error from the results. Errors. Let's first let's get the first error and then get the description of this error. Otherwise, we'll return our user ID. Now go to the API project, the program class. Let's add a post endpoint. Map post. Going to have API users. Then the handler is going to be in the sync function. Let's add the create user requests TL. Call this key. Now let's inject the IUser service. User service. We're going to await user service. User service. Create a sync. We add the request, and that will be all for now. Before we test this, let's add the iUser service to our DI container. Go to dependency injection, then add services. Let's add spoke. We're going to add this as a spoke service. iUser service. Service. User service. Now return services. Turn the collection back. I think with this we're good. We're going to run our application right now to test it. Open the API project in the integrated terminal. So That's one. All right, so application is running. We are going to use the Thunder client to test the API. The Thunder client is a VS Code extension. Where is Thunder client? Now, if you don't have the Thunder client installed in your VS Code, go to extensions and search for Thunder client. Okay, this is it. This is the one. Go to the Thunder client, go to collections, create a new collection. We're going to call this collection Study Lounge. Study Lounge. Now, inside the Study Lounge collection, we're going to create a new folder. This folder is going to be called users. Inside the users folder, create a new request. This is going to be create user. Of course, it's not a get request, it's a post request. You place that, copy the server URL, paste it there. Yes, API users. Good. Now we're going to add the body. The body is just some payload of email. Let's use my email or my obis code. My obis code at gmail.com. Password will be pass. With this password, we are expecting an exception to be thrown by the user manager because this password does not meet the requirement, password requirement. So, but then let's test it out. All right, so password must be at least 6 characters. This exception is being thrown by the user manager as a way of error handling, right? Now we are going to add the actual password that will be validated correctly. Passwords must have at least one uppercase character. All right, so let's make this be an uppercase. Beautiful. Application was created. The user was created and the user ID was returned. If you go to the database, go to ASP.NET User and view first 100 rows. You will notice that the user has been created and registered in our database. Copy the server URL, paste it there. Yes, API users. Add the body. The body is just some payload of email. Let's use my email or my obis code. Password. Pass. With this password, we are expecting an exception to be thrown by the user manager because this password does not meet the requirement, password requirement. So, but then let's test it out. All right, so password must be at least 6 characters. This exception is being thrown by the user manager as a way of error handling, right? Now we are going to add the actual password that will be validated correctly. Passwords must have at least one uppercase character. All right, so let's make this be an uppercase. Beautiful. Application was created. The user was created and the user ID was returned. If you go to the database, go to ASP.NET user and view first 100 rows, you will notice that the user has been created and registered in our database. Now, if you don't have this Thunder Client extension, go to extensions, search for Thunder Clients. Okay, this is it. This is the one. Go to the Thunder Client, go to collections, create a new collection. We're going to call this Study Lounge. Now, inside the Study Lounge collection, we're going to create a new folder. This folder is going to be called users. Inside the users folder, create a new request. This is going to be create user. Of course, it's not a get request, it's a post request. Replace that, copy the server URL, paste it there. Yes, API users. Now we're going to add the body. The body is just some payload of email. Let's use my email, my toll@gmail.com. Password. Pass. With this password, we are expecting an exception to be thrown by the user manager because this password does not meet the password requirement. Let's test it out. Password must be at least 6 characters. This exception is being thrown by the user manager. Now we are going to add the actual password that will be validated correctly. Passwords must have at least one uppercase character. So let's make this be an uppercase. Beautiful. The user was created and user ID was returned. If you go to the database, view first 100 rows, the user has been registered in our database. All right, now the next thing we're going to do is to move the endpoints. We're going to move these endpoints to the create user class in order to maintain the feature slice design pattern and a clean program class. To do this elegantly, we need to add a package called Kata. This package will help us group and manage our minimal API endpoints. Now go to your application project and open it in the integrated terminal and the Kata package. You can now go to the user feature folder, create user endpoint class, public class, create user endpoints. Going to inherit the item module. Implement the interface. Go to your program class and copy our endpoints. We don't need this anymore. Take it out. Take it out. Go back to your create user class. Paste it here. All right. So import the namespace. So the next thing to do is to register Qatar to our service collection and add it to the endpoints route builder. Go to the dependency injection in the application project. Let's duplicate this guy, convert this to add application. Let's organize our dependencies in a logical manner. That's why we're doing this. So remove all of this and add kata. Add kata is an extension method from the kata library to add kata to our DI container. Now the next thing is to add kata to the endpoint route builder. Public story endpoint route builder. We're going to call this map endpoints. For this builder. All right, direct this builder dot map pattern. Create this. Lastly, we're going to update these extension methods in the program class. Go to program class, builder dot services dot add application, and also add our app.map endpoints. Remove this. Now let's run our application once more to test our application out. Okay, it's been running. Let's run it again. .NET run. All right, so go to Thunder Client. Test this again. Okay, let's add digits to our email just to give it a distinct feature. Let's send. Our endpoint is working perfectly. All right, so the next thing we are going to do is to add this to the git. Yes, there is git add status git commit as the user feature, create user endpoints. Status. All right, so congratulations for making it to the end of the first part of this tutorial series. I believe you got something out of this. If you haven't already, please make sure to subscribe and hit the like button, and don't forget to click the notification bell so you get notified when next I post a new video. If you have any questions, or if you're curious about anything, if there's any part you didn't understand, or you want to share some ideas, then feel free to comment down below, and I'll do my best to explain what's going on in the code. That being said, thank you so much for watching, and I hope you learned something new. I'll see you in the part 2 of the series.